Okay, so we're going to discuss these group properties. So the very first group that we talked about yesterday was group 1A, and we said those are the alkali metals. How many valence electrons do they have? One. What do they all end in, their electron configuration? NS1. What does the N stand for? The period number. Do they want to gain or lose to get to an octet? And we said an octet is 8 valence electrons. Lose. And how many does it want to lose? 1. Now when it loses 1, what does its ion charge become? Plus 1. Type of element? It's a metal. And the reactivity is very high, especially with water. Some extra info we put in there about the alkali metals was that they are soft and silvery, and they conduct electricity. Any questions about the alkali metals? So if I were to ask you about the alkali metals to list their properties, you would go to this chart and you would get that information from there. Group 2A is called the alkaline earth metals. They have how many valence electrons? 2, which means their electron configuration ends in NS2. Gain or lose? How many? Lose 2 to get what type of charge? Plus 2. These are metals. And their reactivity is high. Extra information. They are white and malleable. And what else do we know about them? They conduct electricity. So that catches us up with yesterday. So now let's start with group 3A. Group 3A. Oh, wait. The transition metals, they're not part of the A group, so they don't have this group property here. But what we really want to know about the transition metals is the following. So right down here in 3, we're going to put that they conduct heat and electricity. These are malleable. They're very shapeable. And they're less reactive than the other 2 groups that we just talked about. These are the metals that we see in everyday life. These naturally occur: gold, silver, platinum, zinc, all these, copper. All these are things that we use a lot of because they're less reactive. Okay? Jewelry, all of our jewelry is made out of it. I wouldn't want jewelry made out of lithium because it would burn my hand and explode, okay? So these are things that naturally occur. The other elements like lithium and sodium, we have to actually make those from compounds to get that sodium. So this, when somebody talks about a metal, this is what they're talking about, the transition metals. Group 3A. These names are very original. It's just named after the element at the top of the group. So this is the boron group. Number of valence electrons? 3. These are going to end in NS2P1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1 Electron configuration. These are going to lose how many? Lose 3. To get what type of charge? Plus 3. These are metals except for boron. Boron is a metalloid. Yeah. Reactivity, they're not really reactive, so I'm just going to put a line there.
So, can we just put non-reactive?
I would just put, less, you could just leave it blank, or I don't want to say they're non-reactive. I mean, they'll react, but that's just not something we'll, they're less reactive than the other ones, so.
Wait, why'd you put a line through it?
Because they're less reactive than the other ones. They're not real reactive. They're reactive, but not real reactive. You could put less reactive than the other metals. Except for B, for boron.
Could you put low?
Low. You can put low. If you got to put something there, you can put low. Any questions on the boron group?
And, yeah.
Yes.
Robert said, like, highest energy electron or whatever.
Uh-huh.
It's NS2P1 because it goes to the 2 S's and
Yep. Yep.
and
Group 4A. What do you think its group's name is? The carbon group. How many valence electrons do you think it has? 4. What do you think its highest energy level is? NS2P2. Gain or lose to reach dot temp. These are really, they really don't care, so I'm just going to put like a line there. It could go either way.
So plus 4 or minus 4.
Plus 4 or minus 4 if you want. Ion charge, plus 4, minus 4 if you want, or like I said, these are pretty stable. They're chill. Type of element. So I would say that carbon is a nonmetal. And then the rest are metals or semi-metals. That's what the M/SM means. Metals or semi-metals. Metalloids, yes. Metalloids. They have metal properties and non-metal properties. You can put low. What do you think group 5A? Are we seeing a pattern here? Patterns, trends. Group 5A's name is going to be the nitrogen group. How many valence electrons? 5. Highest electron configuration? NS2P3. Gain or lose? Gain. How many is it going to gain? Gain 3 to get a charge of
Negative 3. Wait, why is it gain?
minus 3. It's at 5 electrons. Is it easier to gain 3 to get to 8, or is it easier to lose 5 to get to 8?
Oh, so it's just going back down.
Yeah. You're looking at the valence electrons.
Oh, it's at 8, like.
To get to 8, to get to the octet. All right, type of elements. These are going to be, this is a mix of them, but we're just going to say non-metals. With some metals and metalloids. Again, these are pretty chill. The reactivity are a line through it, or low if you want to put low. 6A, what do you think the 6A's name is? Oxygen group. How many valence electrons? 6. And what is its electron configuration? Ns2p4. Gain or lose? How many?
Gain 2.
To get what type of charge?
-2.
And these are nonmetals.
Low.
Reactivity is high.
Very high.
Yeah, go put them on. Next is going to be very high, right?
Group 7A, this name is the halogens. Oh, tricked y'all. Halogens. How many valence electrons? What is their electron configuration end in? Ns2p5. Gain or lose?
Gain 1.
For a charge of?
Negative. Positive. Negative.
And these are nonmetals. And these are very highly reactive. Very high. I have some additional information about halogens. The additional information is they're volatile. Can somebody tell me what that volatile means?
Unstable.
Unstable. So if it's in liquid form, it's going to easily go to a gas. It's like they easily turn into another phase. So these are volatile and they are diatomic. And what does diatomic mean? Occurs in twos. So diatomic. So if it's by itself, it's going to have two of them hooked together. Lastly, group 8A, noble gases. They have 8 in the outer shell, Ns2p6. They do not gain nor lose. They're ion charged. They don't make charge, so it's a 0 if you want to put it there. Type of element, they are nonmetals. And these are non-reactive. What additional information do I want you to know? I want you to know that helium has 2 valence electrons. These are monoatomic, which means they occur in ones. They don't have to have that twin. And they have a full valence shell. Monoatomic. Yes?
Why does the 4, even though it's more stable, but why does it not still gain or lose 4?
There's an 8.
I mean, it just depends on the situation and usually, and kind of what element you're talking about. Like carbon is mostly going to be sharing electrons, whereas tin and lead, they do something else. So it kind of just depends on the type of metal or non-metal that you're talking about. Okay, lastly, I need you to take a look at the rare earth metals. Rare earth metals. These are, some are radioactive. These are silvery gray, and they conduct electricity. Okay, so if you're looking at this, you can see there's a pattern once we go through row through, get to group A and we go down to the next period, it repeats. And then we go down to the next period and it repeats. If you're seeing here, you have the high alkaline earth, high reactivity, and the high reactive oxygen group. These two are probably going to want to hook up because one can lose 2 electrons while one wants to gain them. And it's the same thing as when we're talking about the alkali metals with the halogens. They're going to want to hook up because one wants to lose one while the other one wants to gain. Okay? Any questions on that? So the last thing that I would do is on your periodic table is I would, at the very top, I would do just like I have on mine, and I would put those charges, +1, +2, +3, plus or minus 4, -3, -2, -1, 0. If you would like, you can put the number of valence electrons at the top. Or at the bottom, valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. That way, when you have that periodic table, you can quickly go and you can find that information and you know. This is what it has.
What does it say? Oh, you just numbered them on the bottom.
Yeah, I just numbered them on the bottom. Valence electrons. If you already numbered them, I just didn't have to. So this is quick access information for you. Any other questions? So tomorrow we're actually going to talk about what these atoms look like when the actual atom itself as we go across the periodic table. Any questions? So I'm going to pass out your test review. You can answer. I mean, you're not going to have any in-class time to work on it, so I would, if you have extra time right now, I would work on that, so that way you don't have to wait and do it on the weekend. Yes?